Master here. Welcome back to my channel, and sorry that I have not posted very recently because I have just been hammered with work. So in this video tutorial, I've been asked by probably well over 10 or 12 people now about critical sections on both um, different like forums I've been on, people I know, and just some of you guys have commented that I really should like do this to help out the Delphi community and whatnot. Um, Critical sections are extremely simple, so I think I can try my best to explain them to you guys. And I've created a visual sample here that we're going to be using, and that I'll try to display to you like how they work, if you will. So without any further ado, let's go ahead and dive in. I'd really like to try to keep this video as short and as simple as possible, because we've really already covered like multi-threading. Critical sections, technically speaking, I mean, programmers, like, professional developers will tell you, yeah, like critical sections are highly sought after only when using multiple threads, like in multi-threaded applications. And although that's true, it's also false, because critical sections don't have to be just used with threads. I've seen many different case scenarios where they were used without threads. There, you can kind of consider them gates that kind of help you, I guess, protect like certain data from being accessed from other parts of your application. And yes, it is true that it's mostly true with multi-threading that you would even consider using them. But I have had other case scenarios where I didn't have to utilize threads and still use them, and they were still very well, useful. But anyway, in this example, we are going to be using multi-threading with it because it is, the mostly sought after and used like stuff. So let's go ahead and get started. First off, what is a T-critical section or a critical section? Um, a critical section is, in the most base form I can explain to you, it is simply a block of code that you wish to have executed and not interrupted, bothered, changed, or anything else other than the thread that currently has control over it. In other words, it's a block of code that is critically needing to be executed and not bothered until it is finished being executed and modified. One of the most simplistical ways that I can try to visualize this for you is to create a visual forms application like this, and then create two threads that are going to fight each other for control of the graphical interface, basically. And when I say fight for control, they're going to fight over the control of the label as well as the progress bars. Okay? So whenever the user, I'm going to quickly explain this to you guys. When you click this button that runs the threads, two anonymous threads are going to be created in memory, and they're going to run. Both of them have the exact same code programmed into them. The exact same code, all right? We're going to keep up with these threads via their IDs, which are going to be thread number 1 and thread number 2. Again, that's an integer, 1 and 2. That's it. So when we click this button, thread 1 and thread 2 instantly are created and start up in memory. And both of them are trying to update the label with I'm thread 1 and I'm in control, I'm thread 2 and I'm in control, or something similar to those lines. And it's also going to try to step every single one of these at the same time by 5 until they get to 100. Okay? Now, let me make this very clear. When these progress bars do reach 100%, every thread, meaning thread 1 and thread 2, both will die. They'll just simply terminate and do no more. Okay? So let me show you what this looks like. I'm going to run this, and I'm going to run the thing with the button. So I'm going to click this, and you're going to notice that when I do, thread 1 and 2 are going to be kind of changing here very quickly, and you're going to kind of see it. It takes a sec, so just kind of bear with me and really watch carefully. And I'm going to run this several times so we can see what it's doing. But I'm going to click the run button, And see how it says thread 2, thread 1, thread 2, thread 2, 2, 1, 2, 1, 2, 1, 2. It kind of was instant there for a couple of times. That's because they both barely got control. And it's nearly happening like this because they're practically running very close to the same round of milliseconds. And what I mean by round of milliseconds, you'll understand when we get into the code. They run at the same time. They're both waiting very similar time frames until they're finished processing whatever data they need to process. But if I run this again, you'll see that thread 2, thread 1, thread 2, thread 1, 1, 2, it goes like 2, 1, 2, 1, 2, 1, 1, 1, 2, 1, 2. See, they're both able to take control and up these by 5. Which is exactly correct. But you notice how there's no errors, there's no lag, everything is beautiful, right? Like I can drag this around, nothing happens that's in bad taste, right? That's because this is a very good multi-threaded application that's running and processing exactly as it's supposed to without interference of the main VCL graphical user interface thread, which is perfection, by the way. Amazing. It's exactly what you want to see. So let's go ahead and dive into the code of this thing and see what we've got. So whenever the form gets created, this will be the first thing to happen is when the form gets created, we're going to create a T-critical section that's going to be global. Now let me go up to the top of the code here. In our private declarations, we have our critical section, which is a type T-critical section. And we also have a thread count, which is an integer. Okay? So when the form gets created, the critical section is now becoming a T-critical section create. So every time we call the critical section, we're using this one that's already been created. Okay? So it's a globalized critical section. Only one of them exists for the entire run of the entire application and the scope for what we're doing. We have a thread count, which is set to 0 because no threads are running other than the base VCL GUI thread, but we're not going to count that, right? And then I'm just initializing my progress bars, which actually we could just remove all this, but I'm not going to. I'm going to leave it just so you guys can visually see here in code. We set the min and max in the position of all the progress bars. Progress bar 1, 2, 3, and 4. Okay, done. Great. Moving on. If we double click the button, so when the program is running and the user clicks on the button, this is the code that's going to fire. We've created a thread 1 and a thread 2. They're both type of T threads. Okay? First things first, we're going to disable the button so the user can't keep clicking it because they're already going to be running in memory anyway. And we only want the button enabled if the threads are not running in memory. We're going to reset our progress bars back to 0. We're going to set the thread count to 0 because obviously nothing's running yet. Then we're going to create our 2 anonymous threads and we're going to execute them. But this does more than just create them. We're creating an anonymous thread 1 and 2, but we're assigning it to this procedure, which is execute thread. However, here's the thing. This execute thread portion here, it's expecting an integer value. So if you'll notice, down here, this is the execute thread procedure for tform1. I told it to expect a thread ID as an integer. So whenever I say thread 1 is actually just the number 1, and thread 2 is actually just the number 2. Got it? And then we just simply call them to fire them in memory and start them up by calling thread1.start, thread2.start. It's that simple, guys. You create 2 anonymous threads, you assign them an event, and the event has their ID number that will pass on to the thread, 1 and 2. Okay? So now, once you click the button, boom, all this fires. They start up in memory. And now we're going to go down to execute thread. So this is where we're at. So both threads are now firing this highlighted code in memory over and over and over and over until they're finished. So we have an integer for looping. We're looping from 1 to 20 because, again, it's going to step the progress bars by 5, right? 5 times what is 100? 20, right? So we're going to step it from 1 to 20. And we're going to see if we can do this until the progress bars reach 100. So here's the part that you've all been wanting to learn about, right? The T-critical section. We have to tell this current thread, whatever ID it's doing, whatever thread manages to get to this critical section enter first is the winner for this round, right? So this thread will say T-critical section enter, and the code that I'm highlighting, all of that code must execute. Well, actually, if you want to get technical with it, all of that code gets to execute no matter what. Well, no, I guess the whole thing. We'll just super technical with it. The whole bit of code here between the enter and the leave, all of this code gets executed without interruption from other threads. So until we call leave, this code is basically going to go no matter what. It is going to happen inside the context of the current thread that managed to enter the critical section first. So let's go ahead and go through this. So we're going to loop from 1 to 20 times, and we're going to begin entering our critical section. Okay, we're going to put try. So once we've managed to go into our loop, we're going to enter a critical section, and we're going to say we're checking first if are the progress bars complete. Now that's actually a different thing that I wrote. So let me go to that event, or that little thing here. The function, it's actually going to return Boolean. I set the result equal to if the positions of all the bars are 100, then it's true. Otherwise, it's false. So we're checking, we're saying, are the progress bars complete? Yes or no, true or false. If it returns true, we break out of this, which causes this thread to basically terminate itself, okay? That's easy enough to understand, right? Which means also, in case you guys get a little confused, this critical section enter right here, if the progress bars are complete and it's true, by breaking out of the loop, we come down to finally, and then we come to leave. You get that? You follow me so far? So the break breaks us out of the loop, and then we turn the critical section off by leaving it so that other threads can do their business as well. You see that? It's perfect. All right, so we're going to enter our critical section. We're going to check and see if we're already done and see if the progress bars are already complete, because if they are, we need to break out and we need to notify the user that the threads are done and re-enable the button and all that good stuff. But let's pretend this is not. Let's just go. So we're going to call tthread synchronize, and we're going to synchronize these two procedures. The update user interface label with the thread ID. Now remember, guys, this is the thread ID of the execution thread that's in the context of the execution thread that's currently being messed with, right? Follow me so far? So we're going to update the label with the thread ID. Now we're passing the thread ID as an integer to the update UI label. The update UI label is expecting a thread ID as an integer, and it's changing the label's caption to I'm this thread, this is me, is in control, right? So this thread ID is in control, right? So if I run that, you guys can see that when I run it, it says thread 2 is in control, thread 1 is in control, thread 2, thread 1, 2, 1, 2, whatever, yep. And then it says all threads are finished when it's done. So now let's go back down. So we're going to update these, and then finally, we're going to leave the critical section. Now, after this has been called, if the other thread just happens across the code and tries to loop and it manages to get into the critical section, then the other thread will be locked out, and it'll be the other thread that's in control. You kind of get what I'm saying there? Like, so one thread tries to fight. It's like a battle between them. One is in control, two is in control. Sometimes two lasts longer than one because they're out of sync in memory. Because the millisecond time frame, which I sleep them at, is half a second. So if they get off over 500 milliseconds is the only way they're going to be able to go into that critical section and actually be able to do anything. I don't know if you guys get that or not, but it's really super simple. Okay, so this the second portion, we're going to talk about another critical section that I wrote in. So this other critical section is, let's say that all this work is done. So let's say this thread did its job, and it is currently sleeping for half a second. And let's say that while the sleeping is being done, the other thread might be in control of them, of the of the GUI and whatnot. Well, after this 500 milliseconds, this thread is not actually finished yet because it has to create another critical section. It increments the thread count, right? And then it does a synchronize of check threads finished, which if you will see down here, it simply says that if thread count equals 2, then the caption is equal to all threads are finished, right? And then it re-enables the button. And then it leaves the critical section. Again, thus allowing only one thread at a time to say, hey, is the thread count actually 2? And then it updates the GUI. It updates the label and the button. So only one thread at a time can possibly update the graphical interface. You get that? So let's think. So I think I pretty much explained it, guys. It's really basic, really super simple. I really hope I'm explaining this in a way that you guys can easily understand. It is so, so basic. I wonder if I actually put a, wonder why I wouldn't need a decrease in here someplace. I was actually curious about that myself. Looks to be all good. I honestly don't think that I've allowed this to go. Oh, I see. I think I understand. Basically, whenever you click the button, it only goes to 2 once it's finished. I get it. I get it. That's pretty cool. So yeah, this is for no more a basic example as this is pretty much perfect code. It might could be made a little better, but I hope you guys easily understand that when you run the application and you click the button, the threads fight over control of the graphics of the graphical interface and the values of these progress bars and the text of this caption of this label. You see that? Once they are finished, both threads will be terminated because inside of the thread code of each current running thread, like I told you, we're checking to see this last critical section portion. We're actually checking if the threads are finished, which brings us to this procedure, which says if the thread count is equal to 2, and remember this is all being synchronized, if the thread count is equal to 2, then we update this label and say all threads are finished, and then self button enabled is equal to true. I'm also going to go the extra step and show you guys something. If I click run, and we pull this up in Task Manager, you can see the critical section application running here, and I'll pull it on over. As you can see, we currently have 5 running threads, right? So if I were to run this program and run this and make the 2 threads create, it goes from 5 and it should go up by 2, which makes it 7, right? So there's 7, and so both threads are trying to fight each other for control, and then they die. It goes back to 5. And there you have it, guys. That is how that works. That's how you use critical sections. So again, to reiterate, a critical section basically is just a block of code that you would like to execute, and you don't need it to be bothered by literally anything at all. Most especially other threads. Other threads need to stay out, right? So anything that we enter a critical section, this code between the enter and leave will be executed in its own thread, and it will not be bothered or touched by any other thread until you have called the critical section's leave procedure. That way, Windows can delegate other threads and let them use this memory space or whatever you were trying to do in here, okay? So I really, really hope that I've explained this well enough for you guys. If you need further examples or code, feel free to ask. Again, I'm sorry, I've been so busy lately, I haven't been posting too many videos for you guys, but I do intend to do a lot more, and if you have ideas for me, go ahead and post them. I know we have a couple of guys that have been asking for like Socks 5, like reverse socks. So, and I do have code written up for this, but I just have to take the time to get everything formulated into a video. So if you guys will just give me some time, um, I've just been dealing with some life stuff, so new job, new everything, right? So I haven't had too much time to get on YouTube, but in any case, I'll be uploading all of this code for you guys to be able to look at. Um, I may spiff it up a little bit, so the code from the video that I just showed may be slightly different, but I'll just kind of go through it and do some like tweaking here and there to make it a little bit more professional. I'll leave this code, but you don't really need it. Again, the progress bar stuff, you can control all of this from design time. There's no need to go through code and do all this crap like I did. So you can remove that whole block right there if you don't really want to use it. It's fine. Just make sure the progress bars are set to 0 position and they have a minimum and a maximum of 0 to 100% integer. Anyway, alright guys, so that's probably where I'm going to end this video. Again, comments, questions, feel free to ask. I really hope this helps some of you guys out. So this has been a very simple tutorial on how to use critical sections in Delphi, how they're properly used. I wish I had more advanced stuff to show you guys, but honestly, maybe sometimes simple is the best, right? Because, I mean, this is the most absolute basic visual example I could possibly think of. And again, we'll run it one last time, just to see what it does again. So if I click the button, both threads are trying to fight for control. Thread 2 has control. Sometimes thread 1 manages to get in there, you see, and then all of them are finished. We can run it again. Thread 1 is in control. Thread 2, thread 1, thread 2, thread 1, and thread 2. So it finished out with thread 2 that time. And that's all because, and I hope you guys are totally getting this, because of the millisecond time frame we give them. So as one is actually doing work, you have to understand that as one of them is actually performing deeds up here, that's actually taking time off its wait milliseconds down here, and the other one is still processing at the exact same start time that we started both of them at. So they're kind of both getting offset from milliseconds in memory, if you will. You get my point? So like whenever one of them gets offset, that offsets them so that then they both start to fight. You see, that's when they both start to fight each other. But the best part is, because of our critical section, it's not going to screw up. Like, if one of them can't enter the critical section, it's literally still attempting this like so many times, but it's not going to ever be able to do anything until the critical section is left behind by the other thread, so that the other thread, the one that doesn't have control, can gain an enter on it and perform its deed. You see? So that is that. And guys, I will see you in some of the next videos. If, again, comments, questions, concerns, whatever, feel free to ask in the comments. I hope you guys have a blast coding in Delphi, and I will catch you guys in the next videos. Peace out.